Hey everyone, welcome back to the AP Pre-Calc Unit 1B exam review video. Let's get right into it. Alright, so the first question we have here is we want to find the x cubed term on the expansion of x minus 5 to the fourth. So what we want to do here is this is going to be, we're expanding a binomial in the form of a plus b to the power of n. So if we kind of compare this to our problem here, we have a as our x, b should be -5, and then our n should be our degree, which is 4. The first step we want to do now is write out Pascal's triangle. So remember, that is just a bunch of ones going down the side, with the numbers inside being the sum of the two numbers above it. So 2 is 1 plus 1. We have 3 and 3, and then we have 4, 6, and 4. That's as much as you'll need for this problem. So once we have that, then we want to take row n. And remember, this first row is not row 1, but row 0, row 1, row 2, row 3, and then this is row 4, which makes sense, right? It has 4s in it as well. Once we have that, we want to take those coefficients and kind of space them apart. So 1, 4, 6, 4, and 1. And now we want to add our a term, which is x, and raise it to the power of n, which is 4 on the leftmost term. And then going from left to right, we are going to add in a terms, but decrease the power by 1. So this should be x cubed, x squared, x to the first, and then this is technically x to the 0th, which is always just going to be 1. Now for our b term, we're going to start from the right and add in this, which here b should be -5. So let's change that now. And then this should be to the power of n, and we are going from right to left this time, decreasing the power by 1. So 5 cubed, -5 squared, -5 to the first, and then -5 to the 0th. Right? What's the coefficient on our x cubed term? That is going to be this term right here, which our coefficient should be 4 times -5 to the first, and then times our x cubed, which is our term that we're looking for. So that should be our coefficient, which aligns with answer choice A there. All right, so question number 2, we have h of x is a rational function where it is f of x, which is 3x squared minus 5x plus 12, all over g of x, which is -x plus 1. And we just want to find the slant asymptote. And so remember, anytime we're trying to look for the slant asymptote, this is going to require polynomial long division. So what we have here is this should be 3x squared minus 5x plus 12. We're going to put that top fraction on the inside, and then -x plus 1 on the outside. And now what we want to do is take our leading terms. We see 3x squared on the inside, -x on the outside, and set up a fraction. So if we do that, we have 3x squared over -x. This should equal -3x. That's going to be our first term, and we're going to want to align that on our other x to the first term. Now we take -x plus 1 and multiply it by -3x. This -3x times -x is positive 3x squared, and then -3x times positive 1 is -3x. Now remember, you want to subtract both terms. So 3x minus 3x is 0. That should always be the case. And now, make sure you don't make this mistake. -5x minus a -3x is technically going to be the same as -5x plus 3x, which should give us -2x, not -8x. We can also drag down that plus 12. And now we're going to do the same thing, take our leading terms and set up a fraction, which this should cancel out to give us just positive 2. And so that should be our coefficient. We now have a linear equation, so this is our slant asymptote, which correlates with answer choice A there. 3, the rational function r is given by x plus 4 over x minus 1. What are all the intervals where this is greater than 0? So that is our rational inequality that we are trying to solve. The first thing we want to do is see wherever the numerator or the denominator is going to be equal to 0. The numerator should be equal to 0 at 1, or the denominator should be equal to 0 at 1. The numerator should be equal to 0 at -4. So plot those on our number line, so -4 and +1. Once we have those, we want to see if they are open or closed circles. Because it's just less than, or if it was even just greater than or less than, those two would have all open circles. If it was less than or equal to or greater than or equal to, then only the denominator would have open circles. The numerator values would have closed circles in that case. But we don't have to worry about that for this problem. So both of those would get open circles. And now we can test values that are in between each interval. So I'm going to use a different color for testing values. So here we have -5, we have 0, and 2. And so we want to plug them into the function r of x, and we want to see, are we going to get a number that's bigger than 0? Or another way of saying that is, are we going to get a positive number? So plugging in -5, -5 plus 4 is -1, over -5 minus 1 is -6. This is equal to 1 over 6, which is positive, so this should be a check mark. If we plug in 0, 0 plus 4 is just 4. 0 minus 1, -1. This is -4, which is not greater than 0. So this is going to be an x here. Plugging in 2, 2 plus 4 for the numerator should give us 6. 2 minus 1 is 1. This is equal to 6, which is greater than 0. So that is going to give us a check mark there. And so in terms of our solution set, it's going to be any number that's less than -4 or greater than 1. We can write these this sign chart into interval notation by writing -infinity all the way up to -4, not including it, so we're going to put a curly bracket, union, and then anytime a number is greater than 1, not including 1, so that's why there's a curly bracket there. And this matches with answer choice A. So A should be our correct answer here. All right, number 4, the graph of y equals k of x is a transformation of k of x equals 3 f of x minus 4. The point 6, 7 is on the graph of f, maps to what point on the graph of k? So what we want to do first is just identify our transformations. We see that 3 out in front of the f of x, because it's out in front, it's going to be a vertical transformation. And because it's multiplied, it's going to be a vertical dilation by a factor of 3. We then see -4. That is also on the outside. So that's going to be a vertical translation of -4 units. Both of these are vertical transformations, which means that they are both going to affect our y values only, which means because we don't see anything that happens on the inside of the function, our x value should remain the same, right? And so we have 6, 7. Let's take a look at the first transformation. We have a vertical dilation by a factor of 3. That's going to take our y value and multiply it by 3 to give us our new coordinate, 6, 21. Our second transformation here is a vertical translation of -4 units. That's going to take our y value and subtract 4 to give us a transformation of 6, 17 as our new coordinate, which aligns with option A. All right, number 5. The rational function has a 0 at x equals 6 and has a vertical asymptote at x equals -3. Which of the following could be an expression for m? So here, if we have a 0 at x equals 6, that would correlate with the linear factor x minus 6. And if it's a 0, it should only be in the numerator. All right, so that's very important here. And so let's see which functions this applies to. So A, we see it in the numerator and the denominator, which will not make it a 0. Here, we don't see x minus 6 in the numerator. We just see it in the denominator. Here we only see x plus 6, but that's not the same. So D should be your correct answer, where this is only in the numerator. Now, however, for a vertical asymptote, that means that linear factor of x plus 3, remember, take the opposite of the number for those linear factors, and this should just be bottom heavy if it's a vertical asymptote. Which, just to double check, in D, x plus 3 is bottom heavy because it's only seen in the bottom, so making D even more of the correct answer there. All right, number 6. This was a question that was very commonly missed on the quiz, so I decided to retest it in the test. The rational function f is given by that equation, which of the following statements is true. Now notice how the first parts of these are almost all the same, right? So we are going to be specifically looking at input values of f sufficiently close to 1, so as x approaches 1, corresponds to output values of what? And this is what we're looking for, is what is our answer to that limit statement there. So first, let's identify what is 1 in this function. We see the linear factor x minus 1, and we see it is equally heavy, which means that it's going to be a whole when it's equally or top heavy, right? Because it is a whole, x equals 1, that means that we want to find the limit statement as x approaches a whole, in which case what you're going to do, and a lot of people fail to do this, is cross off that whole. Simplify the function as much as you can. We can cross off an x minus 1 from the top and the bottom, and you should be left with x plus 3 all over x plus 1. Now we can plug in 1 and not have any domain restrictions or domain errors. And so plugging in 1, we get 1 plus 3 over 1 plus 1. This is obviously 4 over 2, which is just 2. And that is what our limit statement should be here. It should just be 2. So input values of f sufficiently close to 1 correspond to output values arbitrarily close to 2. What this would look like graphically is if we have this point 1, 2, there's going to be a hole there. And as you get closer and closer to that hole from the left and the right hand side, you're going to approach a y value of 2. All right. Number 7, the function g is constructed by applying 3 transformations to the graph of f in this order. Let's take note of them. We have a horizontal dilation by a factor of 4. We have a vertical dilation by a factor of 8, and then we have a vertical translation of, not by a factor, but by -3 units. All right, so let's write an equation relating this. So we have g of x equals f of x, and let's fill in what we know. First, we have a horizontal dilation. Anything horizontal will appear on the inside of the parentheses. So let's do this in blue. Will appear on the inside of the function, and because it's a dilation, it's going to be multiplied. And because it's horizontal and on the inside, it's going to do the inverse of what it looks like it should do. So here, if it's technically by a factor of 4, you're not going to see 4 on the inside of the brackets. You're going to see the reciprocal 1 over 4 on the inside. Let's take a look at the next one. Now we have a vertical dilation by a factor of 8. This is vertical and a dilation, so it's going to be a number on the outside multiplied. And because it's vertical, it's going to be straightforward, which means we can just put that number 8, that factor, out in front. And then finally, we have a vertical translation by -3 units. Vertical translation is going to be on the outside. It's going to be subtracted or added to that function. And then here, because it's -3, it's going to be straightforward, and -3 is just going to be tacked onto the outside. The equation that this matches up with should be, looking at our option choices, should be A. So A is our correct answer there. All right, number 8. The graph of y equals f of x is shown above. What is the transformed graph where this is our transformation? So let's identify our transformations, and instead of saying horizontal translation and vertical translation of -3 units, let's just say graphically what's happening, right? So if we see an x minus 1 on the inside, that's moving it right 1 unit. And if we see a plus 2, that's moving it up 2 units. So we're going to take every point on this graph and move it right 1 and up 2 to get our new point. So doing that real quick here, this should be our new graph. Sketching it like so. And so the one that this matches up with is just looking at one point. This point is at -3, 3. And the only graph that starts at -3, 3 is C. So C should be our correct answer here. Number 9, the graph of x consists of 3 line segments shown above. The graph of p of x is the result of transforming the graph of k. Which of the following gives the transformations from k to p? So here, this is our original, and then this is our new, and we want to see what is happening. So sometimes it helps if I actually sketch the new graph on the original and just kind of look at it at the same graph. So doing so would look like that. We can kind of see here, and this is something that you just have to be able to see, is this is a vertical reflection over the x-axis, right? So it is reflecting the graph vertically from the top to the bottom. Now, what does this look like in terms of an equation, right? You have p of x, and then how is this going to affect k of x? And so, because it's vertical, it's going to appear on the outside, and because it's a reflection, you're just going to add a negative sign out in front. And so this correlates with answer choice A, which should be our answer there. All right, number 10. This is one of the 4 short answer questions that you have on your exam review. I will pick 2 of these to be on your exam. All right, so the graph of function g is given by, we have the factored form, and then we have standard form as well. So remember, factored form is really good for telling us info about holes, zeros, and vertical asymptotes, where standard form is really only good at telling us stuff about end behavior and horizontal asymptotes. So we're going to keep that in mind when answering these questions. For one, determine the x values of any holes in the graph of g of x, or state that there are none. So here we see, let's identify any hole, zero, or vertical asymptote that we see here. So zeros, or let's identify any linear factor first. I think that's going to be the best way to work through this problem. So here we see x equals +5. This is going to be top heavy with a degree of 5 over a degree of 4, which means it's going to be a hole. Next, I see x equals 0. This is also only in the numerator, and so this should just be a 0 just from that. All right, the next one I see is this x minus 9, which means x equals 9. This should be only in the bottom, so this is going to be bottom heavy, which means it should be a vertical asymptote. We then see x equals -3. This is going to be equally heavy, which means it is going to be a hole. And then finally, we see x equals +2. This is going to be bottom heavy, and so that is going to be a vertical asymptote there, just because it's bottom heavy. All right, so first off, number 1, determine the x values of any holes, or state that there are none. We should see 2 here, x equals 5, and then x equals -3. Should be our answers there. Part 2, determine the equations of any vertical asymptotes. Here we should see 2, x equals 9, comma, x equals 2. Should be our two answers there. 3, determine the equations of any horizontal asymptotes. So that we want to look at standard form, and this is why I only have the first two terms and the last term, because you're only going to look at your first term, and it will be in sequential order by degree, so you don't have to worry about that. Having this, we have an x to the 7th over an x to the 10th, which this is going to be a bottom-heavy rational function, which means we're going to have a vertical asymptote at y equals 0 for any bottom-heavy function. So this should be y equals 0. Part 4, find the x value, or find all values of x for which this equals 0. This is another way of saying find the zeros, which this is, ironically enough, 0 is our 0. That won't always be the case, but this is an example of where x equals 0 is in fact our 0 of the function. Finally, we have something talking about end behavior. This is determine the end behavior of g as x increases without bounds. This means as x goes to positive infinity of g of x. And then this, because it's bottom heavy, whenever there is a horizontal asymptote and you are looking at your end behavior as x goes to positive or negative infinity, if the horizontal asymptote exists, if it's not a top-heavy function, your end behavior will just be that horizontal asymptote, 0. So that should be our answer there. All right. Number 11, we have a graph of a rational function that is shown above. We are given that there's a hole at 2, -6, and we can see the vertical and horizontal asymptotes. Part A, AI, write the equation of the line that is the vertical, which remember vertical is up and down, asymptote of R. This is seen at x equals 1, so that should be our vertical asymptote. Part 2, write the equation of the line that is the horizontal asymptote. This is seen at y equals -2, and that should be our horizontal asymptote there. All right, part BI, determine the end behavior as x decreases, and then the second part is as x increases without bounds. Express your answer using the mathematical notation of a limit. So here, this is talking about end behavior. I'm going to write the limits off to the side just for more space, but this should be the limit as x decreases, so as x goes to negative infinity, and here as x increases without bounds of r of x is our function, so make sure you have that, equals, and now we have a horizontal asymptote like we just found at y equals -2, so that should be what our end behavior is, which is this is equal to -2. Right? And then the final part, evaluate the following limits. Here we are looking as x approaches 1, which is that vertical asymptote from the left and from the right-hand side. From the left side, as we get closer, we are going up forever. So this is going to positive infinity from the left. As we get closer from the right, we're going down forever. So this should approach negative infinity from the right. So that is our end behavior there. Now taking a look at as x approaches 2 from the left and from the right, that's at that hole 2, -6. So right there, this is as the limit as x approaches a hole is just going to be the y value of that hole. So both of these should be -6. What this looks like on the graph, and it's kind of hard to see, is at 2, -6, there's that hole there, and as x approaches from the left and from the right, it's going to approach both of times, it's going to approach that y value of -6. So that should be our answer there. Part CI, find all the intervals for which r of x is less than 0. Express your answer in interval notation. So here, we want to highlight any parts where this is going to be greater than 0, or less than 0. And so where it is below 0, this should be this line segment right here. and then this whole line segment right there. And so we want to include those two portions of the graph in our answer. So first off, let's cover this part right here. This is going from x equals negative infinity all the way up to that 0 is at negative 1. We're not going to include negative 1 because it's not less than or equal to, it's just less than. The next portion is we want to go from 1, which is that vertical asymptote, all the way up to, and we actually don't want to include our whole, so all the way up to positive 2, that whole. And then we want to start at that whole from the other side, so we just want to exclude that exact value at 2. And here we're going all the way to positive infinity there. So that should be our answer for CI. Let's look at CII, which is write a possible equation in factored form for the rational function r of x. This is going to be the trickiest problem, I think, on the test, if you see it. And so this is because we want to identify everything that we can from the graph. And so we should see a vertical asymptote at x equals 1. We should see a whole at x equals 2. We should see a 0 at x equals negative 1. And we should see a horizontal asymptote at y equals negative 2. Now, how do we introduce all those things into an equation? So let's see. Here we have r of x equals, and we want it in factored form, which is going to be nice. So first off, if we have a vertical asymptote at x equals 1, that's going to be a bottom-heavy factor. So I'm just going to put that once at the bottom as x minus 1. Now we have a whole at x equals 2. So I'm going to put that as an equally heavy factor there. I have a 0 at x equals negative 1, so that should only be seen in the numerator. So x plus 1 right there. And now this is the hardest part. Right now, if we factored this and or if we expanded this and found our leading terms, right now we have x squared over an x squared. And our horizontal asymptote, because it's equally heavy, would be y equals 1 as the equation currently stands. However, we don't want that, right? We want a horizontal asymptote at y equals negative 2. So for this to happen, we need it to be equally heavy, which it is, right? X squared and x squared. However, we want the ratio of these coefficients to be negative 2. So what we can do actually is take this number 1, and we can multiply that top equation by negative 2 by throwing a negative 2 out there. And this should be our correct answer for part CII. All right, number 12, let g be a rational function defined as g of x equals f of x over x squared minus 9x plus 20, where f of x is a polynomial. Write one possible expression for f of x such that the graph of g has a whole at x equals 4. So what we want to see here is we want to first factor that denominator. So this is f of x over x minus 4, x minus 5 is how you would factor that. And if we want a whole at x equals 4, right, we want that linear factor x minus 4 to be equally heavy or top heavy. Let's just, so these questions may have tons of answers where the answers may vary, but here we want it to be equally or top heavy. Let's just go with equally heavy for now. And so f of x, let's just make it x minus 4, right? That way, then when we plug x minus 4 in, we would have x minus 4 over x minus 4, x minus 5, where this is equally heavy, and that would be a whole at x equals 4. So that could be our answer for AI. For AII, write a possible expression for f of x such that it says the graph has a horizontal asymptote at y equals 2. So remember, horizontal is going to be based on n behavior, and so if we have a horizontal asymptote at y equals 2, this needs to be equally heavy, where in the denominator, our leading term is x squared, so we want this to be an x squared as our leading term, and then we want the ratio of the coefficients to be 2, so we're probably going to want a 2x squared term, so you could have f of x equals 2x squared, and you could have other things attached to the end because it won't really matter, and that's why I say answers may vary. Or you could just have f of x equal 2x squared, where then when you plug it in, right, 2x squared over x squared minus 9x plus 20, those are our two leading terms, they're equally heavy, and the ratio of the coefficients is 2. So that is 12a. 12b, let f of x equal x plus 4 and x minus 5. And remember, the denominator is x minus 4, x minus 5. Identify any vertical asymptotes for the graph of G or state that there are none. So let's take a look. Here at x minus 4, we know x equals 4 is a vertical asymptote. And at x equals 5, that is going to be a hole. And if you wanted to, you could find x equals negative 4 is a 0. So the only vertical asymptote should be x equals 4. That should be our answer. And now for partbii, this is going to be polynomial long division. So if f of x equals 2x cubed minus 6x squared minus x minus 1 all over x squared minus 9x plus 20. Find the equation of the slant asymptote. So this is going to be polynomial long division. Show the work that leads to your answer. And so what we want to do is first take a ratio of our leading terms. We have 2x cubed over x squared. This is 2x, so that's going to go above our x term. And then multiply this whole thing by 2x. So here we get 2x cubed minus 18x squared plus 40x. Subtract it. 2x cubed minus 2x cubed is 0. Minus 6x squared plus 18x squared is 12x squared. And then minus x minus 40x is minus 41x. You could drop that down, that minus 1. And then set up your ratio again. So 12x squared over x squared equals just positive 12. And that is our equation. You can stop there. Y equals 2x plus 12. All right, for 12c, let f of x equal to negative 2 times x minus 9 cubed times x plus 1 cubed. Evaluate the following limits. So this, if we have negative 2 times x minus 9 cubed times x plus 1 cubed all over x squared minus 9x plus 20. We take a look here, we're looking at n behavior as x approaches positive or negative infinity. And so what we're going to want to do is we're going to want to get that top equation, f of x, into standard form. Now remember the trick. And the trick is, if we have an equation in standard form, what we can do is we can cross off any lower power term inside the parentheses. And so this really just becomes, that numerator just becomes negative 2 times x cubed, which is negative 2x squared, all over an negative 2x to the 6 over an x squared term. So here, if you have negative 2x to the 6 over x squared, this is going to simplify to negative 2x to the 4th, which this will have n behavior like negative x squared. So that should be the n behavior. So this should be negative infinity and negative infinity as well there because it's top heavy. All right, for 13, we're given the graph of a rational function. First, we want to determine the x values of any holes or state that there are none. We should see a hole right here at x equals 3. So that's part 1. Evaluate the following limits. So limit as x approaches -2 from the left-hand side. This should be -2 is right here. So the -2 is that vertical asymptote. And this from the left-hand side is going up to positive infinity. Now here it's the right-hand side. This is going down to negative infinity. Part 3, determine the equation of any horizontal asymptotes or state that there are none. There is one at y equals, this is hard to see, but 1. So that should be our answer for part 3. Part 4, determine the end behavior of f as x increases without bound of f of x. So this, because there is a horizontal asymptote at y equals 1, that's going to be our end behavior, just 1 there. And then for part 5, determine the x values as decimal approximations for which f of x equals 2. This should just be -3, should be our x value that equals 2 there. All right, now here we get to the graphing calculator section. I'm going to throw the Desmos graphs up here and then just kind of walk you through it. If you have any questions with Desmos, please come see me during office hours before your tests so I can go over those with you. It's a little harder to show it on the lesson videos here. All right, so we're given a cubic function, and then which of the following is not a 0? So all you want to do is just enter in that function at face value in Desmos, and then hover over your 3 zeros. Remember, zeros are where it crosses the x-axis. You should get 3 points. I marked them, but as long as you can like hover over them and then just like write the coordinate down, you don't have to mark them like I did. So our 3 here is -0.109, so we can eliminate that answer choice because we're looking for which one is not a 0. The next one, 2.332, we can eliminate C, and then 9.329, so A should be our answer there. In this case, this is actually the location of our y-intercept. Was that like fake answer there? So A is our correct answer for number 1. All right, number 2. The function v gives the number of vehicles available for use or available for sale at a used car dealership. We want to find, with a cubic regression model, what is the value of when we plug 29 into the equation? What value are we going to get as a potential estimate? So the first thing you want to do is hit this plus and add table. Once you get here, enter in your data points just as you see them. This should go right here. And then these values should go in your y1s. Then you want to, it will tell you what type of regression to use. It says so twice here. So we want to use a cubic regression, so hit that drop down arrow. To get this part right here, there should be like 3 dots, something that looks like this up there, so you would want to click on that. Once we have our regression equation, there's 2 different ways that you can do it. I show both ways here. You could either copy this equation down, paste it in a new equation, and then change y to f of x, and then find f of 29 to get your answer. This is going to be very close to 36.700, rounding. So C should be our correct answer. If you don't want to do this way, that is totally fine. You could just graph the line x equals 29, and like I show here, find your intersection point, which this will again round to 36.700. So C, either way, should be our correct answer. All right, number 3. The rational function r is given by this. At what values does the graph have a hole? And so remember, this is a tough question for a lot of people. So I'm going to show you with a really easier example before I solve this problem. All right, I give you that function there. Where is there a hole? And it's pretty easy, right? X equals -2 is a hole. And why is it a hole? because it is where the numerator and denominator are both equal to 0 the same number of times, in which case there's a quadratic function, and so both of these are quadratics and they both have two different zeros, so we want to see where they both equal to 0, just like how both of these functions are equal to 0 at x equals -2. And so what we're going to want to do is take this function as equation 1, take this function as like equation 2, graph each one separately, and find where they both equal to 0. Here we see 2.68, and so that should be our answer. So A is our correct answer there. All right, number 4. This is that 6-part question that I was talking about in 1.14. I will go over how to solve each section and exactly what I will be looking for. So for 4A1, we want to use the given data to write 3 equations to find the constants for A, B, and C. But first, let me just take a minute to explain the context of the story. And so the table gives the number of ice cream cones sold by a food vendor at the initial day, day 0. He sold 14 cones. 35 days later, he sold 57. 10 days after that, or at day 45, more importantly, he only sold 46. The number of cones sold can be given by a quadratic function I, where this is at squared plus bt plus c. This is very similar to just a regular quadratic function, ax squared plus bx plus c, where I of t is the number of ice cream cones sold on day t. So t is in days, and then our I of t is number of cones sold. All right, so we want to just use this data, use those 3 points that we were given to write 3 equations. So we have 3 coordinate pairs. You got 0, 14, you got 35, 57, and then you got 45, 46. We want to write 3 equations by plugging in our xy coordinates in for x and y in this function here. So this is very important. The first equation should be 14 equals a times 0 squared, don't forget the squared, plus b times 0 plus c. And I actually would encourage you to not simplify these equations. The next one should be 57 equals a times 35 squared plus b times 35 plus c. And then the next one is 46 equals a times 45 squared plus b times 45 plus c. So notice for part 1, or AI, we do not have to solve any of these equations. We do not have to simplify. If you just give me these as your answer, you would get full credit. So that would get you 1 point there. All right, part 2. Find the values for A, B, and C as decimal approximations. So here what you want to do is now use Desmos, which you will have access to for this whole question. Plugging in your x and y values, we are going to use a quadratic regression line because that's the type of line that we were given there. This is our equation, and so we want to pull our numbers from that equation, where this is a t squared or x squared plus b of t plus c. So here we can literally just say a equals, b equals, and c equals, showing no work. And remember, decimal approximations means 3 decimal places. So the first one should be negative 0.052. If you had 0.051, that would be okay. B should be 3.0, and the 6 would actually round it up to 0.40, so that should be the value of B. And C would just be 14. You don't have to add 14.000. You could just leave it as 14 and be okay. All right, so just remember A, B, and C are your coefficients from that quadratic regression equation. All right, for B, I, this is use the data to find the average rate of change. Another word for that is slope. Between 35 and 45 days, express your answer as a decimal approximation. Show the computations that lead to your answer. So here, if we take our two coordinates, we have 35, 57, and then you got 45, 46. A lot of people ask, why don't we use 0, 14? We were given that point as well. And this is because we're looking specifically from 35 to 45 days. It's not really asking about 0 in this case. All we want to do now is plug it into the slope formula. So remember m equals y2 minus y1 over x2 minus x1, which is going to be equal to 46 minus 57 over 45 minus 35. This should give us negative 11 over 10, which if you just left this would be wrong, which then we want to convert this to a decimal approximation. So negative 1.10, that should be our answer there. All right. Part B2, or BII. Use the average rate of change found in Part 1 to estimate the number of ice cream cones sold on day 40. Show the work that leads to your answer. So I know I didn't, for some classes I explained it, and for some classes I didn't. The easiest way to memorize this one is to use point slope form from Algebra 1, which here it's y2 minus y1 equals m times x2 minus x1. Where here we are given, we want to find day 40. So day 40, and then we don't know our y value. That's what we're looking for. And here for our other pair of coordinates, we can use either one of these two. It doesn't matter. So let's just use 35 and 57 here. And then our slope is negative 1.10. And so plugging this into this point slope form, this can be x1 comma y1, and then this can be x2, y2. So y2, which we don't know yet, minus 57 is going to be equal to m, which is negative 1.10, times 40 minus 35. This is y2 minus 57 equals negative 1.1 times 5. This then, I'm going to continue my work up here, is y2 minus 57 equals negative 5.5. Adding 57 to both sides, you should get y2 equals 51.5, which should be our answer here. So 51. Geez, let me erase that and rewrite that a little nicer. So our answer should be 51.5 cones. Or if you want to actually round this to 52 cones, so it makes sense in the context of the question, that is fine. If you want to truncate it to 51, that's fine too. As long as you show your work like this, that should get you, and then get 51.5 at some point, and I can see that number. Even if you round it, that should get you full credit. All right, part 3, this is the hard part. This is let A of t represent the total number of ice cream cones sold per day using the average rate of change found in part BI. For A of 40 found in part BII, it is shown that A of 40 is less than I of 40. Explain why this is the case. In between 35 and 45, give a reason for your answer to the graph and the relationship to A of t. So let's break this down, right? If we look at this graph, right, you should have 35 and then 45, and then we have 46, and you got 57. So we have those 2 points there. The quadratic function should look like this, right? So this is going to be our I of t. And then we also have a straight line, which we use for slope, and this is our A of t. And when we looked at 40, if we look at here, 40 here, it can be shown that A of 40 is less than I of 40. And this is the case anytime the line is between 35, and 45 there. We want to kind of have tunnel vision on that area of the graph. We don't really care about anything else. And so, what would be a good explanation? Well, this is how I would give my explanation, and then I'm going to show you what I'm going to be looking for. I would say A of t is less than I of t from 35 is less than t, which is less than 45, whatever this is here, because I of t is concave down, and the secant line from t equals 35 to t equals 45 is below I of t. Right, that would get you full marks, be a perfect answer. And the reason for that is because you hit the two things I said in class that I'm looking for. The first thing is that I of t is concave down. That's the first part. And then the second part is you address or talk about the secant line from t equals 35 to 45. And you put it in a nice complete sentence. If you just have bullet points, I'll take off a point or two. Because I want a smooth sentence like this, but this is good. So that would be like the minimum that you would need to write for like this question. All right, part C. Explain how the range values of I should be limited by the context of this problem. So this 6-part short answer question actually came from a practice exam, and so this is the rubric for that part C that I'm going to read out loud now. Explain how the range should be limited. So remember, range is talking about your x and your y values, or just your y values, sorry. And so the lowest our y value can go is 0, right? The number of cones sold, we can't sell less than 0. And the highest we can go is that maximum at 29.371, 58. 0.640. All right, so that should be like our range here. And so their answer is, based on the context, the range consists of non-negative values, right? So this is another way of saying can't be less than 0. Because I is a quadratic function whose graph is concave down, there is a maximum, right? Because it's concave down, and there's going to be a maximum there, which is 58.640, rounding to 3 decimal places, which means 58 or 59 ice cream cones. They don't care which way you round, whether you round down or up, if it is something that you can round up for. So I would accept either one. And then they say the proposed range is 0 is less than or equal to I of t, which is less than or equal to 59. For like this type of problem, as long as you talk about one endpoint, so either there or how it's less than 59, that would be fine. And then give a reason for your answer. So that would be what I'm looking for, is just a reasoning as well in terms of the context, right? So that would be our answer for that final part. This review will be very, very similar to the actual exam that you will take. And just as an extra benefit to anyone that actually stayed through the entire exam review, watched the entire exam review video, the first 5 people to come to me and ask me what my favorite ice cream flavor is, I will give you some extra credit on the test. All right, but only for the first 5 people, so make sure you're quick about it. All right, I will see you guys later, and have a good one.